Everybody see the screen okay?
Yes, I can see it.
All right, awesome. All right, so tonight we are got not a ton on the agenda, but there's a lot to look at and hear about. So the first thing we're going to do is just look ahead a couple weeks at our data analysis. Give you a little bit of preview of what that's going to look like. So as you think about last week and you're listening to what we're talking about tonight and next week, you're able to formulate in your head maybe a little bit better some of the things that we're going to want to be talking about after that. And so I'm going to just quickly introduce that to you. We've got three engineers here from SiteLogic, Gavin, Brian, and Jeff, who are going to walk through part one of the engineering assessments that have been ongoing at the facilities in the district. And then if we have time, I've got a small group activity. And if we don't have time, we will kind of push that off. We're going to be spending a lot of time talking about this stuff as a group, but nonetheless, if we have time, I do have a group activity for us. So as we look ahead at this data analysis preview, what we're going to do is in 2 weeks after we get through the engineering assessments, what we're going to do is divide up into small groups, 5 or 6 people in a group, and you're going to be able to self-select, if you will, into kind of a category or a topic area. And I listed the topics there. Might tweak them slightly between now and when we do them, but the topics there are indoor air quality, which kind of covers CO2, radon, mold, ventilation types of things. We'll talk some about that tonight, or not tonight. Yeah, I guess we are, whatever. The guys will talk about it when they talk about it, but that'll be coming up. Learning environment, which kind of includes temperature, humidity, lighting, acoustics. That I do know we're talking about tonight. Infrastructure, so electrical, building envelope, which is walls, windows, roofs, plumbing, hard surfaces, that kind of thing. Safety, security, and accessibility, fairly self-explanatory. And then organizational arrangement, kind of an odd terminology there, but basically kind of the stuff we talked about last week: school location, enrollment size, program accessibility, some of the facility equity issues. So you're going to be able to self-select into that through a survey process. We'll get about 5 or 6 people into a group. I know there's people who are going to want to talk about probably more than one of those things. And so we're going to do this twice, all right? So you'll have an opportunity to select 2 different groups or subject matters to talk about. And when we go into those groups, we're going to talk about a couple of different things. And so the first thing is, what do you see with kind of the data and the presentations that are there? What jumps out at you as being important? And do you see anything there that's interfering with the vision or the strategic objectives that we've talked about that were part of that strategic plan previously? Then we're gonna ask the question, what else should we be asking? So are there some things that we still need to explore deeper perhaps? Is there some additional data that we need in really trying to understand where we're at today with this information? And then what's important, at least relative to the information we're reviewing here or reviewed so far. So what actions at this point would you potentially recommend to the school board? Understanding those may change as we continue through the process. And then what actions should be prioritized? What are the priorities there? And so we'll go through that exercise. We'll give you a little bit of a background too, and give you some examples on what some previous recommendations to a school board have been, kind of trying to keep the end in mind. But those are the questions that we're going to try to get our heads around on some of this information that we're going through. And so, like I said, we're going to do it two times. So you'll have two different subject matters that you're able to pick to have those conversations. And if we've got 10 people that want to all talk about indoor air quality, for instance, we'll do 2 groups that are doing that. So that's just to keep in the back of your mind as we go through tonight's information, next week's information, and as you kind of consider last week's information as well. So is there any quick questions to that? I'll be sending a little bit more information out on that, but any burning question on that before we jump into the engineering stuff? All right, then I will push forward. I just want to draw attention again to our meeting norms tonight. Just a couple again to highlight. We've been actually pretty good on this, but assume positive intentions as we're hearing from folks and as we're talking through this stuff. Some of it I know sometimes is a bit tenuous as far as subject matter. That's okay. That's good. You know, we like to address the elephants in the room sometimes. But assume positive intentions at least. Share the air. Everyone's voice is important. Let's make sure everybody who has a comment, has a thought, has a question, has that opportunity to provide that. And let's just make sure we've got the environment that allows people to feel comfortable coming forward with those questions. And lastly, it's really important as we're going through this information in particular to really keep that district-wide focus as opposed to an individual family focus or an individual building focus. We really want to keep that district-wide focus as we go through this. So I just wanted to recall our attention to that. I am going to turn things over at this point to the engineering team that's been working on the assessment stuff in your facilities. Gavin Benson, Brian Peters, Jeff Seawald are all engineers over at with SiteLogic, have been engaged with the district for quite some time now. That engagement continues. And so they're going to take us through a lot of the things that they've seen from an engineering perspective. This is part one, by the way. There'll be two parts to this. And I'm going to stop sharing so you guys can jump right in.
Thanks, Tom. I know that Brian's going to be sharing his screen shortly, so I'll just kind of pause until it populates on everybody's screen. Okay, so as we get started, can you hit the next slide, Brian? The reason that we're talking about what we're talking about tonight is the Grand Forks School District has a vision. They have a strategic plan, they have a technology plan, a financial plan, and they're trying to kind of align those and look towards the future to make them sustainable. And tonight, we're going to talk about where we're at today. Why don't you click one more slide, Brian? And specifically, we're going to talk about student performance and how the environments in the buildings impact the learning environment. One more slide, Brian. And Tom introduced us, but maybe with a little bit more introduction. For those of you who haven't met, my name is Gavin Benson. I'm the program team leader for SiteLogic. A lot of you have met and seen and heard from Brian Peters. He is the group leader. He's working hand in hand with Chris, your Buildings and Grounds Director, and Scott, your business manager, to identify all of the needs at all the buildings throughout the district. So tonight we're going to start sharing some of that information. And Brian asked one of the subject matter experts to join us tonight, Jeff Seawald. And Jeff is an expert in the systems that control the environment. So if you think about your cell phone being very current and it's got algorithms, lots of capabilities. And if you think about an old rotary phone, that's kind of the spectrum of systems you have in the facilities. So he's going to talk a little bit about that tonight. Can you hit one more slide, Brian? Thank you. And as we look at the planning process, as we work with other school districts like yourself, there's a couple different ways to identify needs. So there's physical needs, those are the buildings, and there's also educational needs. So we've been hearing in the last couple of weeks from the demographer about student capacity, the functional capacity of the buildings, enrollment projections. The city planners have talked about where the town is growing. The district has talked about special needs and mental health and curriculum. So we've been sharing some of that, but tonight we're really going to talk about physical needs. One more slide, Brian. And within physical needs, there's a couple different categories. One more slide, Brian. The first one is the indoor environment assessments. And those are the aspects of the buildings that affect occupants. So it can be students, it can be staff, it can be visitors. And hopefully this summer we all get together and go on some building tours. They're going to be affecting us. So we're going to learn about what those impacts are. And then, as Tom said, next week we're going to be doing the second category, which is kind of in the middle there, the system report cards for all the buildings. Those are, as the buildings sit today, all the different systems, as you imagine the roof all the way down through the building into the hard surfaces and throughout. So it's a lot of different, a lot of data to do in one meeting. So that's why we're having two meetings. And then a little bit further down the road, we're going to talk about optimization. And not surprisingly, just given the size of your district and the amount of years that have gone by since there's been a large planning effort, there's some room for improvement. But that's a good thing because you're already spending money on budgets to do certain things. And if we can make that situation better through optimization, since you're already spending that money in the budget and we can save that money, it's not going to have an impact on the taxpayer. So just because of the amount of work that probably needs to be done throughout the district, that's going to be a great way to reduce or lessen the burden on the taxpayers. Okay, one more. All right, so this is my favorite slide, and probably not for the reasons you might think. It's a bit of an eye chart. There's 16 categories that are assessed when they're looking at the buildings. We're going to do a bit of a mental exercise tonight, and it might sound a little bit corny, but in a few moments, I'm going to ask you to close your eyes. We're going to close your eyes, and we're going to kind of do a visual walkthrough of a building for maybe 30 seconds to a minute to help set the stage for Brian, because he's trying to talk about a subset within a building. So bear with me, but we're all going to close our eyes now, no peeking. And we're going to imagine standing in front of a building. It can be any building, and not any building, any school. It can be the school in your neighborhood. It could have been the school that you went to when you were a student. You're standing on a sidewalk and you're looking towards the front door. We're going to start walking towards the front door. And as we look left and right, we're going to see things like grass, maybe playgrounds, maybe parking lots. And as we approach the front door, there's going to be a gentle grade up to that threshold. Maybe at Central High School, there might be some steps, but we get to the front door and we reach for the door and it's locked for safety reasons. So we hit the buzzer and there's a little camera there and it lets people know who we are. So they let us in and we go to the front office, we check in, we sign in, we get a badge of some sort. So the teachers and staff know who we are. They can kind of account for us checking in and out. And there's a big sign that says meeting this way. So we start heading down that hallway and we stop at the bathroom. We want to wash our hands because of just kind of the current events right now. We want to reduce the spread of germs. And then after an appropriate amount of hand washing, we leave the bathroom and we walk down the hallway to a classroom. And as we walk into the classroom, we take in the whole scene. There's desks and there are cabinets and there's maybe some windows. There's technology on the wall. It could be a smart board. It could be some sort of audiovisual devices like TVs. We're going to look up. There's going to be some ceilings. And what does it feel like? Is it bright and sunny out? Is it the right temperature? Is it too hot, too cold? Is it too humid? The things that we can't see behind the scenes that are in the ceilings, in the walls, in the floors are the things that Brian's going to be talking about. Those are the systems that provide comfort to us. Just like your body has a brain, like the computer systems that control your buildings, and like your heart, there's motors that pump water throughout the buildings. And just like pipes, just like your veins, there's pipes within the buildings that kind of are taking the water. And everything that you're visualizing right now is and was part of a budget. So those are assets that the school district has, and they need to be maintained over time. So, okay, so everybody open their eyes if you close them at all. And once in a while, I put people to sleep. So we're just going to take a second and take a breath and maybe roll your shoulders a little bit. One more slide, Brian. So specifically tonight, Brian's going to be talking about a subset of the categories, and those are the systems that affect the learning environment. So I'm going to turn over to Brian, and then I'll be back to talk with you later on at the presentation.
Thank you, Gavin. And that was fantastic. A good virtual tour and kind of get everybody ready to think of ourselves sitting in those spaces that we're hopefully going to see in person and walk around those facilities and get a feel for exactly what it's like. And today, the objective is to share a number of samples of what we observed. And it's just going to be about half of the content. There's so much information we excited to share with you. We split it into 2 meetings. Tonight, the content is going to be focused on primarily the indoor environment and how we feel, how the students live in the space and how it meets the educational needs of those students. We look at the focused on the building environment. We're going to look at a sample buildings. You see Valley is included, Ben Franklin, and others. We're going to talk a little bit about the common themes throughout, and especially where you are at today with the building systems. That will especially be a theme next week. But today, most importantly, how these building systems impact the learning environment. Again, you're gonna, as you take this in, it's a good visualization to imagine how this impacts the students when we're on site, when you're in the building tours, to look for some of these systems that I'm gonna share with you today. So again, as Gavin mentioned a little bit ago, the focus tonight is on the indoor environment assessment. So on the right, it's on the physical needs of the building. These are the assets. So again, I'm an engineer, not an architect, so I'm not going to talk about ADA compliance or other factors that really are important to the aesthetics of the building, but more focused on the indoor environment assessment, the indoor quality, the light, the sound, temperature, and humidity, and how that affects us and affects our students, our children in the classrooms. Next week, a little bit advanced preview is the focus on the asset assessment. So when we look at the assets, the equipment that provides that space, that creates that environment, whether it's the lights, the boilers, the windows, all of those building assets, we'll talk about those as a follow-up to this discussion. But tonight, we're going to talk about how they perform and what kind of things we're looking for. Lastly, facility optimization. That's more for improving the efficiency, whether it's energy efficiency or operational maintenance efficiency. That's kind of, will be throughout it. That won't be a specific topic we're focusing on this time, but we're tonight focusing on the indoor environment assessment. So good visualization. Think about when you're in an environment, how we perceive that environment is what we hear, what we see, and what we breathe or what we smell. So when we look at the environment, we're looking at those from that perspective. That's how we perceive our environment. And those are the most predominant ways we can perceive the environment around us. So when we look at student achievement, a lot of this discussion will be surrounding how our children perform in these environments and what kind of environments help them to perform better. We're looking at indoor quality, lighting, temperature, humidity, acoustics, and lastly, the building environment and the aesthetics of the building. The last topic I'm going to spend a little bit less time on tonight. I think that's a great topic for our architects to focus on. Again, I apologize, I'm not an architect if you're expecting me to be. I'm a mechanical engineer, so I'm really good at those other 4 categories. And I think all of us can relate to some of the building quality and aesthetics when you're walking through a building and you get a good feeling of a flow inside of a building. So I'm going to start off with indoor quality. Next will be temperature and humidity, then lighting and acoustics. So it's a little out of order in terms of the flow. I apologize in advance, but if you're really strict on flow, we're going to start with indoor quality and ventilation. And the reason we're going to start there is because that's probably one of the most significant topics of how we perceive the environment. As soon as you come into a space, if you come into a space that's stuffy or it's not a good environment, you'll smell it right away. You will maybe it feels stuffy or feels cold or feels hot, but that especially the indoor air quality is something that's very noticeable. There's a lot of studies that have been done, a lot of them by the EPA, that relates the ventilation and the indoor quality and student performance. So higher bottom right is actually really indicative today. This was a quote back from the EPA back in 2011, that higher ventilation rates reduce the transmission and spread of infectious agents in buildings. That's kind of a no-brainer if you continuously bring in fresh air. That's a hot topic today, but more importantly, whether or not it's a hot topic today, good ventilation has always been important. If we look at the right in the middle and the top, reducing absenteeism by approximately 5 to 10 absences per 1,000 students. There are studies that have strong correlations to better outdoor ventilation and absenteeism. Now, it's pretty hard to nail down that number in terms of that's the reason you're doing a project. There's a lot of good reasons to increase the outdoor ventilation. What we can say is there are studies that have a strong correlation between absenteeism and better outdoor ventilation. Another focus on it, increasing the outside air ventilation. It's 10 CFM per person to 20 CFM. CFM is cubic feet per minute. That's a measure of the airflow. Bringing in more outside air does cost you more in energy, especially in the cold winters. You're bringing in more fresh air that has to be heated and sometimes humidified, but that brings in more fresh air. That can be more expensive. However, on the other side, you're improving the indoor comfort, and there are studies that correlate that to improving student performance. So why does increasing indoor ventilation improve the environment? Well, the sources of poor indoor air quality, over half the time, it's usually because there's inadequate ventilation. And you might have a space in your house, or maybe your house alone doesn't have good ventilation. You have to open windows. If it's an older house like mine, you need to open windows to get a good ventilation. And even newer houses are even tighter, so they have less ventilation coming into them. And that's one of the major differences between schools or commercial buildings and our houses. Schools and commercial buildings are larger, and there are requirements for a certain amount of outside air per code. And that in ASHRAE standards also recommend it. ASHRAE is an organization of engineers, American Society of Heating and Refrigeration Engineers, that have prescribed recommendations for proper outside air ventilation. But sources of indoor air quality, a lot of those are just attributed to bringing in more fresh air. Sometimes in the rest of the cases, there are indoor pollutants, and you have some of those examples in your district right now in West with some mold that you're addressing right now, which is also microbial issues. But furnishings, there's outdoor pollutants if you don't have a good filtration system for the fresh air that you are bringing in, or perhaps you have a lot of windows that are left open, and that those pollen and some of that comes in, that also reduces the indoor quality. So all of these issues, one of the major solutions is to bring in fresh air properly. As I mentioned, you do have some examples of indoor air quality. I'm not going to focus on these, but in the packet that we have, and if you haven't already received it, I do have these 2 pages bookmarked or included as a snapshot for your reference. Please go to these web links. These are on the district's website. You can download on the left, the inspection reports is for the mold testing, and the right is the radon reports. And when we have schools, both of these, I'm going to address both of them. And in terms of both of them generally, whether it's mold naturally occurs and exists everywhere. But where it becomes a problem is when it exists in large amounts and it becomes airborne. And then that's when we breathe it in and it affects us. And it affects some people even more significantly than others. If you have asthma, you can tell right away if there's mold in the space, if there's a little bit. So remediating that with fresh air is a great way. Now you also need to address the source of the mold. So that's also part of the solution. It's not a silver bullet just by increasing outside air ventilation, but addressing the source of the mold, whether that's water or wherever that source is. On radon, the radon is a product, a chemical, or I'm sorry, not a chemical, but it's a gas that comes out of the earth naturally, and it occurs naturally, and when we breathe it in, it's harmful to our lungs, and it can cause cancer with extended exposure to it. So I'm not an expert on radon, but there are proper ways to mitigate it. And the only way to discover you have radon is to test it. It's odorless, you can't smell it, you can't see it. So you have to test for it. And when you test for it, you find it, you need to address it with remediation. The remediation is quite simple from an engineering perspective. You just need to ventilate that space of wherever that radon is coming into the space. So if it's a small little sewer area, or if it's a water trap, a small area from the tunnel, maybe the steam tunnel, you just need to properly ventilate that space with a little exhaust fan. It depending on how severe the issue is. But in all cases, we continuously test for it, and you address those concerns when they come up. And if a building fails a radon test, it's usually 1 or 2 spaces, or if there are multiple spaces, whatever spaces those are, they need to be addressed. And Chris, I'm going to call on you a little bit later, so I'm going to give you a test now, but I believe there is just one more space left in the district that you are working on right now to address. And if you could quickly get to unmute, feel free to add on to that. Is that correct?
Yeah, we actually had test results from Lewis and Clark and Valley, two spaces that we are working with the existing HVAC system, and then also did a slight modification to address the other one. Hopefully that'll work. But yeah, those are the only other two spaces that were over the 4 picocurie limit set by the EPA.
Thank you. Thank you. And I'm going to call on you in a few minutes as well for Valley when we get to an example on CO2. So there's my transition into CO2. If there's any questions, if you don't mind holding them to the end, if there's burning questions that come up in chat, please feel free to interrupt me. But otherwise, we'll try to get through this fairly quickly because I want to try to get to the discussions like groups. So I'll try to keep the pace going a little bit faster now. CO2 and cognitive performance. There was a study that was performed by Lawrence Berkeley Laboratories quite a few years ago, probably about 5 years ago now. It was called a number of college students, and what they did is they applied different levels of carbon dioxide in a space. We naturally exhale carbon dioxide. We breathe in oxygen and exhale carbon dioxide. And if you're in a typical space, you have 20 people in a room, you're going to see the carbon dioxide levels increase if you don't have proper ventilation in the space. So carbon dioxide is a good indication of people in a space. It's also a good indication if you don't have good ventilation of fresh air coming into the space. But if you don't, what they studied was the impact if the levels were allowed to increase. For comparison, outside air can range from 350 parts per million to maybe 500 parts per million, depending on the time of the year. It's higher in the winter than it is in the summer. But that's your baseline. So that's what we consider fresh air. If you go outside and smell the fresh air, you're probably around 400 to 500 parts per million of carbon dioxide. That's normal. So 600 parts per million is a well-ventilated space. That's not very high. Above 1,000, once you get to 1,000, that's kind of average. That's typically what ASHRAE recommends and what we control to. If you get over 2,500 parts per million, that's when you start to notice the difference. You can tell walking out of a room that's at 2,500 parts per million into a space, or open the window, you can feel the fresh air, you can notice the difference. That's where the delta, that difference, becomes very noticeable. It's not until you get over 5,000 or 10,000 parts per million where you start to see more severe adverse effects. And quite honestly, in a classroom environment, we're never going to be exposed to that. So just to swing the pendulum both ways from perfect air, you're not in danger if you're at 2,500 parts per million of being sick. You might be lethargic, but it's not till well above 20,000 parts per million that you start feeling adverse effects from the carbon dioxide for a long time. And it's not till much higher, over 200,000, where we have issues with unconsciousness and all those kind of bad things. So 2,500 parts per million is bad, but it's not life-ending. So my point in showing this is that when they looked at the different spaces and they studied people that went into those spaces, you can see at the different levels how they could perform tasks. So looking at how our students can perform tasks in a space that's well ventilated, you can see when the parts per million are up to 2,500, how their initiative drops off, and basic strategy, breadth of approach, information utilization. It's like you're a little bit slower. So it's just a little less motivation. You don't have as much energy, and your mental energy is not there for basic activity. So you can see all across the board, there's a number of ways this affects us. So it's anecdotal. If you've been in the space, you can relate to it. If you haven't, here's a study that really correlates the two. So that's the levels. When we look at 1,000 parts per million is good. 2,500 is kind of the high limit. Anything above that is really where we're starting to see a negative impact. So in your facilities, we did some CO2 testing. So we walked into the classrooms and tested when
Brian, we do not have you on mic. Brian Peters.
Pause for a second.
Am I back now?
Yep. You want to repeat what you said, though? Nobody heard
Okay,
it.
thank you. So in the CO2 testing here at Ben Franklin, we have classrooms that are white, they were not tested because students were not in those classrooms or a window is left open. So it's not a good measure of your ventilation system. So what we're looking for is not bad results. We're looking for how your systems, your mechanical systems are performing for ventilation. And if the room is empty, then it's not an indication of how the equipment is performing. So in this case, you can see we're in that range. We had a room that was under 1,000, which is good. This is a newer area that has a rooftop unit, newer relatively speaking. And you see others over here that are over 1,000 parts per million. The ones that are over 1,000, 2,000 were the ones that more catch our attention. And this wing has mostly unit ventilators. We also looked at the same classroom, and I'll go back to it was actually this room here where we're high. So let's look at what happens in that classroom during the day or during the course of the next day. So overnight, we put in a logger and let it run for the whole next day. And what this demonstrates is what happens throughout the day. So you can see when we did the test, it was a snapshot in time, and this really shows you what happens through the course of the day. So even though we measured 2,100 parts per million, during the day, the levels continuously change. So as they're continuously exposed to something over 2,000 parts per million, that just is a strong indicator for us that the ventilation air can be better. Similarly, at Lewis and Clark, which also has a lot of the unit ventilators, we had some areas that were higher. And here they just over the 2,500 parts per million, but again, the same scenario of the exposure. And here, when we looked at a snapshot of time, some of those classrooms, you can see we didn't get the same results as the instantaneous measurements, but that's because from day to day, the CO2s are always constantly changing. And what we look for is the amount of exposure, amount of time. And what we don't know is if in the middle of the day, the window happened to have been opened, bringing down the CO2, or if it would, so this seems a little odd to me that it would drop so low, but regardless, you can see that there's an effect of CO2 over time. And lastly, at Valley Middle School, this one was a little more interesting because we see over on this wing on the east side, these are mostly unit ventilators on the second floor. Actually, they are all unit ventilators on the second floor. The lower level has an air handling unit that was fairly recent down here in the corner. And on these north end classrooms, this addition are also rooftop or penthouse air handling units. And then over on these wings, these classrooms are served by older air handling units, and they're all in the red, whether they're air handling units or the unit ventilators. And a lot of that can be attributed to the age of the equipment. They're not well commissioned, so they could maybe just need some adjustments, where other equipment like the unit ventilators likely need to be replaced because they're not adequate, even if they're properly commissioned to bring in the proper amount of fresh air. They'll be challenged to do so. So here was the results at Valley, and picking one room, this happens to be on the second floor where there are unit ventilators, and there was a fairly high CO2 level. So we wanted to see it, and I had not seen this before, but it maxed out, it appears to have maxed out our CO2 meter at 5,000 parts per million, which is a fairly high amount. Again, as I started the conversation, it's not a dangerous amount, but it speaks to the ability for the students to be learning in that environment. And the main message on that snapshot or the graph is to show the exposure that it's throughout the day. And I do recall this specific classroom, and Chris, I'm going to turn it over to you in 1 second, but that classroom, I can remember the teacher commenting that it's too loud to keep the unit ventilator on, so they turn it off because it overheats, and it's too loud, mostly because it overheats, the older steam system. But then if you turn it on, you'll get the ventilation air, but then it's really loud. So Chris, what's your experience with those unit ventilators at Valley or other schools?
Yeah, what we're finding is even the unit ventilators that are still operational are being not utilized by the teaching staff, and adamantly not being utilized by them because the sound is so loud that it not only detracts the students from the learning that the teacher's trying to do, but it also raises the overall noise level within the space. And I know you're going to get to that piece here in a minute, but yeah, that's kind of where we're at with that, with those unit ventilators. And unfortunately, they are no longer supported. That's probably a piece that needs to be discussed as well. As we've searched high and low and worked with many different contractors, but the repair and replacement of those units is impossible anymore.
Yeah, it is. And that conversation will come up a lot next week when we look at the specific assets, and univentilators is on the list. But you're right, finding replacement parts, and there are solutions to retrofit a univentilator with a univentilator. Again, we don't recommend that because you're still not changing the dynamic or the challenge of the noise. You're still putting the equipment in the space. That's where air handling units further away help to make that better. But I'm getting a little ahead of myself, but thank you for sharing that experience. On the call, we'll get Jeff Seawald introduced, and Jeff has a lot more experience in this, and I'd really looking forward to Jeff sharing a little bit more about pathogen mitigation. So I talked a little bit about ventilation, but Jeff, if you'd like to take it from here on and talk a little bit about pathogen mitigation.
Sure. Thanks, Brian. Before I do, I noticed there were a couple questions that came up in the chat. I think Whitney had a question, and there was another person I think as well. So, oh, I see. Someone answered but Whitney, what was your question?
I was just curious about the CO2 study that you cited. It was a few slides ago.
Yeah.
What was the size of that study? Do you know?
This was a study we did. So in this case, these are the results of all the rooms that we tested.
No. Before you started talking about the schools, the effects of CO2 on
Yeah, the Berkeley study.
The Lawrence Berkeley study. I can actually find the PDF and send it out. It's actually, if you're interested in the details, it's actually very interesting because what they did is they did 24 people and they conducted a psychological test on them at each of those intervals of 600 parts per million CO2 space. So they would spend 3 or 4 hours in the space. And after a couple hours, they would then take this cognitive test, the psychological test. And again, the study will identify what test that was, but the results of that test gives these results. And it was a group of 24, and they did groups of 3 people at a time, if I remember correctly.
Okay, so do you know if there's, I'm kind of interested actually in that association. Is there like a meta-analysis that's been done of that nature, or are you just citing this one 24-person study?
The funding for this kind of, there's not a lot of funding for this kind of an effort. So for Lawrence Berkeley to get this, I think was the Department of Energy funded it. And it was still, I think it was like under $1 million just to get the study on 24 people, but to control the environment, to set up a space, to have those environmental conditions controlled to that level. What I'll take as a follow-up action to share that study with you. It's a really good study. I have a whole nother 10-minute presentation where all I do is talk about the details of that study, but I'll start with sharing with you. Unfortunately, I would love to find more examples and more studies like that, but it's kind of hard to come by. But that's a good question.
Okay, thank you.
Mm-hmm.
And just for what it's worth, we'll send that out to everyone. And then if you're interested, like Whitney, you can take a closer look. If not, you can disregard it. But we just want to make sure everybody's got it. So we'll send it to everyone.
Kim had a question too.
Wonder what effects breathing into masks has on CO2 levels if that was the classroom in the fall. I think the effect on CO2 levels would not change if you're breathing into a mask or not in terms of the space CO2 levels. Because I think people will still exhale the same amount of CO2.
There's another question there. Does CO2 levels affect kids faster and more severely than adults?
Yeah, that's a great question. And unfortunately, I can't say that I know the answer. However, to me, they are smaller bodies, and I would think that higher CO2 levels would affect them. Again, that's my opinion. I don't have facts to support that. Back to the Lawrence Berkeley study, that was a study of adults for clarification, that was not kids in that study with the effect of CO2.
Okay. All right, good questions, good discussion. As Brian said, I'm just going to give you a snapshot of some of the things we've been looking at for infection risk mitigation in school buildings. That are both short-term and long-term approaches. The short-term focuses more on cleaning existing spaces with a few different technologies. And the long-term approach is actually what we call engineered infection protection. And that is where we can incorporate some technologies in your systems, in your buildings, that can be used over the long term. And they can't completely guard against infection transmission, but they can greatly reduce the risk of infection transmission. So in the short term, we focus on cleaning solutions. Those are fogging solutions. You've probably seen that on the news. I know I have, where people are fogging indoor, outdoor spaces with these fogging machines that they carry around. Those machines are emitting a atomized fog, chemical fog that neutralizes pathogens. The other solution uses light, and in particular UV light. So, you know, the sun emits UV light that we use sunscreen to guard against. Similarly, we can use that similar form of UV light to protect, to clean spaces actually. So that UV light neutralizes pathogens. And that's called UVGI. It's ultraviolet germicidal irradiation. It's kind of a complicated way of saying if we shine UV light on something, we can neutralize it. And so hospitals have used this technology for a long time, and ambulances incorporate this. They turn it on when there's no one in the ambulance, and it disinfects the ambulance. But it basically neutralizes all kinds of pathogens, mold, fungus, bacteria, and viruses. So moving on to the more long-term solutions, and I think, Brian, I don't know if you want to go to the next slide, if we had, yeah, so these are the long-term solutions that we can incorporate in building systems. So we focus on two areas. One is airborne contamination, and one is preventing surface contamination or addressing surface contamination. So on the airborne side, you can see the list there. Humidification it has been known for years to reduce the transmission, especially of viruses. So in hospitals, a lot of times they'll humidify key spaces. Now the key is those buildings are often constructed with humidification in mind. So in other words, they're constructed to keep the moisture in the building even when it's super dry and cold outside, which happens a lot in Minnesota, North Dakota. And schools haven't been, especially old school buildings, haven't been constructed that way. So you have to keep in mind what the building is capable of. But generally speaking, if you can maintain your relative humidity between 40 and 60%, you can greatly reduce the risk of any kind of disease transmission, any kind of respiratory disease transmission. Of course, there's filtration, which we already incorporate in our HVAC systems. However, as noted previously on this call, if you're not running those systems, then those filters can't do what they're intended to do. Then a couple other things we can incorporate in the HVAC systems. There's ionization equipment that we can put in the system that generates positive and negatively charged ions that neutralize pathogens both in the airstream and in the room. So you can't see them, but these charged particles attach themselves to pathogens and steal hydrogen from them, and that effectively neutralizes them. And then there's again UV light, which we can put in HVAC systems. There's also UV light units that can move from room to room. Either people can move them from room to room, or there's autonomous, if you think of a Roomba that moves around and cleans the floor, there are UV robots that move from room to room in hospitals and basically go into a room, turn on their lights for 30 minutes, disinfect that room, and then move to the next room. So, and then there's something called upper air zone UVGI, and that's the same technology, but it's applied in a filter-like device that goes, it's mounted close to the ceiling in a space, and air flows through that device and gets disinfected in that process. So, and the surface contamination, there are things like coatings and antimicrobial surfaces that we can put on high touch areas like countertops, door handles, door push bars. So those kind of antimicrobial surfaces are mostly consist of copper alloys, and copper microbes cannot live for very long on copper, only up to about 4 hours. Whereas glass at the other end of the spectrum is probably the worst material. Microbes can last up to 96 hours on glass. So you think of your phone, you probably want to clean your phone fairly often because they're mostly glass and metal, and the microbes can last a long time on those surfaces. So, and then finally, touchless automation. Automating things that people touch a lot is one way of reducing the potential for surface contamination. So we already often automate urinals and toilets and faucets, but we could also automate high-use doors and other types of entryways. So if you could go to the next slide, that'd be most helpful. So so this returning to your school buildings, these are some of the ventilation systems in the middle schools, and you can see they're definitely aging. So this is at Schrader Middle School and Valley Middle School, and these are the original equipment. So in that time period, the equipment was much less efficient than today, and they're also in somewhat poor condition. So this is an example where we would replace those systems with new air handling units. So
can I just interrupt you real quick, Jeff?
Yeah, of course.
And I apologize. I try not to always interrupt for sure. But when we talk about the whole idea of the pathogen mitigation and some of these types of things, obviously our minds today right away go to COVID and that type of thing. But from a school standpoint, anytime kids are out of school for whatever the sickness is a day that they're not learning. And I know when my kids were in elementary school, they're not now anymore, but we'd get a letter home, I bet every winter at least, from the principal saying, we've got an outbreak of whooping cough going around or whatever, so please keep your kids home if they. And I'm assuming though that the things that you're talking about here really are broad based, right? We're not talking just about COVID here. We're talking about a broad base of health related things.
Yeah, I mean, we've been focusing a lot on them lately because of the current situation. However, a lot of these things are good practice or good things to put in place regardless to keep people healthy. So ventilation that Brian mentioned, reducing the amount of or controlling the amount of CO2 in a space is very important for cognitive function, comfort, but CO2 is a proxy for other things in the space. So if you have a lot of CO2 in the space, you probably also have a high concentration of pathogens, of microbes, of dust. So that controlling that ventilation is probably our number one thing we can do. And that is very broad based. I mean, that's good for everybody, is to have adequate ventilation so that we can focus on our schoolwork, but also avoid, or prevent people from getting sick. So I worked with a school district over the last few years to help them greatly improve their classroom ventilation because they were having so many kids out sick with the flu during flu season, and they felt strongly that it was a function of lack of classroom ventilation. And once we did ventilate properly those schools, we saw the absenteeism go down. So thanks for bringing that up, Tom. If we might focus more on the temperature and humidity in the school classrooms, we can. This is important too. Making sure we maintain the comfort level in the classroom so that students can focus on the work at hand is important. So that's part of the learning environment. And we can go to the next slide. So here you see a temperature map for Valley Middle School. It's important to note that this is, as noted on the slide, this is when it was very cold outside. It was only about 5 degrees Fahrenheit in the wintertime. But you can see a number of these classrooms are quite warm. And so we also mentioned the fact that it's very dry in the wintertime, of course, in North Dakota. And with the warmth in these classrooms, it would be kind of very warm and dry. So you can imagine that's kind of uncomfortable. And it's already winter, so people are probably wearing layers. And so it's very important to control the temperature so that people can teach effectively and learn effectively. Any questions so far? Should we keep moving?
There was a question.
Yeah,
Is there anything we could add to the classroom so the CO2 level could be absorbed, or anything that could break CO2 into O2 and so forth?
That's a good question. There aren't really technologies that break CO2 down, but the most important thing we can do in classrooms to manage is to manage the CO2 level with ventilation. So we bring in outside air into the school, and I mean, your HVAC systems are already required to bring in a certain amount of outside air. A lot of times we put CO2 sensing in classrooms, and then that CO2 sensing tells the HVAC system, hey, I need more outside air. So then it sends more outside air to that classroom. That's the way, I guess, more modern, current state-of-the-art systems work. So does that answer the question?
I think John had a question too. I'm not sure if it's a question or a statement, John.
Yeah, I would agree with
Sorry.
John's statement. He said seems like ventilation's a top priority, and I think we're all in agreement on that here. So
Okay. Yeah, I just wanted to ask if, obviously we're looking at a lot of things, but you guys would be the experts in what order of these would be the most important. Just for when we're thinking about what to prioritize as far as funding and things, it seems like air quality would be the one that we really need to get in check.
it's a good observation. You can go to the next slide. I think we had one more school.
Jared has a question, and maybe, Brian, you can answer that question. How many schools in the district have the air quality issues?
Yeah, that is a good question. It's not all the schools, so don't we're not painting a broad brush. We picked on schools that have issues, that have the older equipment, and typically there's a strong correlation with older equipment usually experiences these problems. So we didn't do the CO2 testing in the Discovery Elementary or even South Middle School. They're newer facilities, and even just walking the space, we know there's not an issue there. So you can tell. And we were in the space, we did a CO2 measurement, but it was average. So we're not going to walk around the rooms and get good measurements in every single classroom. It's kind of it doesn't really add value for us because we already know it's good ventilation. We can tell within minutes. So next week, actually, that'll be a good discussion next week. I think there's a strong correlation in the age of the equipment and we'll talk about that next week. But it's not every building, but it is a lot of the older equipment buildings.
Yeah.
Thank you.
Back up one slide to the temperature map. I know that Chris told us.
Sorry, Gavin, you're really.
Hey, Gavin, we can't really hear you.
Can you hear me now?
I think it's picking up a different microphone.
All right.
Go ahead, Jeff.
But tell you what, why don't you go ahead, Jeff, and we can come back around to Gavin.
Okay. Yeah, while Gavin's fixing his mic issue, I should also, I'll add to Brian's comment, just that the old buildings, years ago, we didn't know what we know today about proper ventilation, and the codes and standards by which buildings were built didn't require us to ventilate them like they do today. So that's a lot of the reason why those older buildings aren't ventilated the way that we would do that today. So another important thing is temperature and humidity again. So this map shows Valley Middle School again, but with cooling and dehumidification and where that's available in the school, so that you can see that's only available in the office areas of the school and a very small portion of the school. And this is pretty common in a lot of schools that we look at. And this has the potential to create issues at the other end of the spectrum, which is, if it's hot and humid in your school for a lot of time, you risk forming mold in the school building, in the building materials, and then you have problems with indoor air quality from mold. So that's kind of the other end of the spectrum when it's, when it's hot out and humid and wet in the spring and in the late summer, early fall. So, and I think at this point we can go to the next slide. And oh, here's Ben Franklin again. This is the temperature map for Ben Franklin. You can see this building has a mix of results for temperature. And again, I believe this was in the wintertime. So you can see there are a few warm spaces, but then some spaces seem to be in proper control. So, and then I think we also have the cooling map for this school on the next slide. And this shows that this school does have a newer system on one part of the building that has cooling, or actually the system's not newer, but it does have cooling. And then you can see that I think the one room is cooled with just a room unit on the other wing. So, so many of the schools are like this. They're partially cooled. So, and I think if I recall correctly, oh no, I got one or two more slides. Yeah. So, a key part of controlling our indoor environmental conditions are what we call building automation and controls. And here you can see some things from a couple different elementary schools as an example, but a lot of the schools have similar vintage of controls. So on the right, the pictures on the right show you what we call pneumatic controls. And they're actually an very old form of control with like air pistons and gauges and valves, and they work by sending air pressure to or from different actuators. So here you actually see those are the actuators that send air to one room or another. And over time, these controls degrade and they don't work as well. And I mean, this is basically like 1960s technology. So sometimes we find in buildings that these systems aren't really working at all. And some of these buildings have been upgraded with what we call digital controls, and you see an example of that on the left pictures. The digital controls usually have a computer interface. If they're really, the current generation of controls, they would have a web-based interface that you can use on your phone, just like your Nest thermostat at home. But here, these controls are actually kind of aging. They're an older generation of digital controls. They're kind of the more early generation of digital controls. So, and they're laid on top of these pneumatic controls. So the combination is really kind of an aging system that needs to be addressed so that we get the proper conditions and proper ventilation in our classrooms in our schools. And I think that's my last slide. I certainly could take questions or hand it back over to Brian at this point. So.
Thank you, Jeff. I did see a question on the CO2 temperature assessments. Were not done in all buildings. In fact, we just finished these CO2 measurements the week of March 9th, and it was the following week that we really started to go in lockdown mode and prohibited from coming back. So we had planned to do more as needed, but we did focus on the buildings that we knew had the issues first. So that was the plan. And we can repeat those measurements. It's fairly straightforward. We have data loggers we could also launch and ship to you and have put into the space. But again, you have to have kids in the spaces to really get those temperature and humidity and CO2 measurements done. So John, that kind of to your question, will any temps be taken during September? You've seen rooms over 100 degrees. That is pretty high. I know I haven't seen that, but I have seen the boiler room get over 100 degrees when I've walked in. That was a sauna. Other questions? Chris, you asked Chris about Chris, thank you for responding to the rooms. That'll be part of the discussion next week, where we'll have much better visuals in terms of which buildings have asset issues in terms of challenges. And so the thing to remember with all of this information, and we're going to talk about lighting in a second, of getting close to the end, but think of the indoor environmental quality and some of these, how they impact the educational environment. How do the kids learn in these environments when you don't have good temperature controls and the ventilation? And I think that's the key. If you take away from from this discussion is with facts, what is the measurements of space conditions? The next one is lighting. Overall, you have lighting systems, a lot of T8 fluorescent light fixtures, and there are many buildings that have some LED lighting retrofits already done. And part of our objective that when we look at the educational environment, lighting is the most environmental input. And I think one of the challenges we've had in the recent past with the advent of more iPads and electronic devices is that sometimes the lights are too bright and maybe not the right color. So depending on the task, you want to change the color, the brightness of the light. There's also a lot of studies with newer technologies like LED where you can actually change the color of the lights from that white/blue look first to a more yellow light, that softer look. There's a lot of studies that correlate controlling environment after the kids are out from recess to have more of a yellow light. That's a calming effect, bring the kids back to be more engaged on learning. And then right before lunch, you have the lights be a brighter white, more sunlight level that will engage them more before people go. And the controls are so advanced that can be programmed right into the sequence of the controllers and do it automatically. There's a lot of capabilities, and one of the best new aspects of lighting is that it's economically viable. There's often an economical payback to implementing newer, better lighting systems. So where do we see that? We see it in the classrooms. We see it on the exterior as well with the older metal halide lights that are kind of a yellow look. It's hard to, from a security perspective, it's hard to distinguish the color of a vehicle. If there's a car outside of a doorway, when you have a yellow light shining on it, you can't tell if it's green or blue or a dark red. Whereas if you have the newer lights in LED, you can better distinguish colors. On the interior, metal halide lights often take a long time to start up, where LEDs are instant on. And you probably can also have a better control of lighting levels, where you have gymnasiums with competition level lights, where maybe it's 40, 50 foot candles, and then during a basketball game, you might be at 70 foot candles. So there's higher levels during those activities. And again, back on the bottom right, where there's portable units, hopefully we don't have those in the future when we look at capacity, but having adequate light levels when it's in the evening or in early mornings, but having good, safe places to walk, especially in the classrooms, to have good lighting in the spaces. And overall, the lighting levels were good from our visits. So last thing I want to focus on, and this is kind of where we're going to round it off, is on acoustics. And sometimes teachers have to yell in classrooms to get their kids' attention, and we know that roughly 60% of classroom activities involve speech, and you might argue more than that, but it's hearing what the teacher has to say provides you direction, provides the learning environment. So adequately hearing the teacher, hearing your classmates give answers is, I guess anecdotally, maybe it's a no kidding moment for most of you, and maybe I'm saying something that's revolutionary, but one of the things we look at, and we want to try to measure or quantify that level of sound, is measuring with a sound meter, decibels. And what we look for is a standard, again, ASHRAE has for background noise levels is 35 decibels, which means when there's no kids in the classrooms and there's no sound coming from the exterior, from the hallways, from anywhere else, and these pictures and these measurements were taken in the evening, going in after hours when that building was essentially empty, and taking sound measurements in different locations. So here in this classroom, the unit ventilator was over to the far left. This 41 decibels where the teacher primarily sits, which is ironic, right next to the unit ventilator. Again, these are sound levels that you hear when there's no other sound, there's nobody talking in the space. So for you you have to speak louder than that to be heard. So you have to speak clearly. In the next one, here's another classroom, again, a unit ventilator, a little bit higher amounts. Again, the front of the classroom is where you can see the student sitting in this desk would be at 49 decibels. And as you get back to the small work table in the back is 41 decibels. So when that unit ventilator is running, this student has to hear something louder than 50 decibels to hear what the teacher has to say. So it's a challenge. And that's one of the things we look for. Again, ASHRAE standards we're looking for is 35. Doesn't sound like a big difference from 35 to 49, but it's a logarithmic scale, which means it's quite a bit louder when you get up even just 10 more decibels. So again, that's the background noise that we want to try to address. couple quick slides on building aesthetics as I round things off, just looking at the aesthetics of a building. Here at Century, a Century is a nice school, but again, some of the challenge when you get to aesthetics is how do we have the student flow through the space? There might be a challenge with the fire safety as well, like things being in corridors, but it's more about furniture or having the environment to be comfortable for the students. So adding storage and lockers in those spaces, being inside of the bathroom. So what kind of space or educational environment is created when you walk into a bathroom and you see a stall missing? Now, overall, we didn't see a lot of issues, but this just are some examples as we look at older aging facilities as to what the aesthetics look like and how that affects students and their ability to learn and their focus on learning. So again, Chris, not intended to be a criticism of you. These are just older facilities that often have challenges in being maintained. Door handles, you see these doors. So you look at the doors, it's like, well, they're older. Some of them are original doors, but you see the door handles are not, they're doorknobs and may not be a big deal to you. But if for ADA compliance, if you have a hard time opening doors, we look for the door handles versus the older ones. So aging doors, non-ADA compliance is what we're also looking for in interior spaces. So the common themes in the learning environment. Go ahead, Tom.
Brian, when you say door handles, I wanted to make sure because you kind of glossed over that, and a lot of people don't understand the ADA compliance is the lever type door handle as opposed to the ones that you have to twist.
That is correct. It's a lever, so you have to grab the handle and press down to turn it open, versus a twist with the hand, which is often harder. And actually, door handles with the door handle is even easier because you could even use your elbow to open some of those doors. Good clarification. So common themes in the learning environment, again, looking at a classroom, you can consider the acoustics, the sound, the background sound of what the space is when nobody's talking. The light levels, this classroom is actually fairly well lit, but the challenge would be, let's say the teacher is standing in the front of the classroom and has the smart board on. Can they control just the lights in the front of the classroom so students can better see the screen? So looking at lighting from that perspective and how technology has changed is a challenge. Temperature and humidity, again, these are older mechanical systems we're going to talk next week about how all these things are interrelated. The univentilator is part of the challenge because of the sound it makes, but it's also the controls and the piping and the steam system that goes back to the boilers. And we'll talk about the boilers a lot more next week, the stuff you don't see, but all of that stuff is interconnected to provide a comfortable learning environment for the students. So the ventilation, the temperature and humidity. And when we look at safety and security, the doors, I will say nearly every single door during classroom hours, we're always locked. And so from a safety and security perspective, I think that you have a strong advocacy in the classroom spaces themselves for being secure. And the doors, the front entryways coming in, so the doors were well locked down, but then from a secure entry perspective, a different discussion, different day, but that's a different aspect, which is having a secure entry for visitors to come in. So they're buzzed in and come directly into, be admitted first before just allowed to walk through the hallways. So looking at a classroom like this is a great example to just consider when we go through the site visits, look at some of those learning environments. Think of the lighting, think of how the lighting controls, how the sound is, how the space environment is maintained. And that does wrap up. Just a summary of this slide was on earlier, just as a wrap up. So what we talked about were some sample of the buildings. We have more details for those samples in a packet of information that is going to be sent out. Some of it applies just to the buildings we sampled. So if the building's not included, we didn't sample CO2 in that building. So everything we tested is in there. And what we also included for every building is the level of air conditioning in the building. So you can consider that as well. And really where you are at today. Next week, there's going to be a much larger data dump and a much more significant, kind of tying all of this together with the educational environment to the assets across the district. So that's where I'm going to end it and look at the questions that may have come up. What percentage of the building total cost is related to air quality equipment? Is it always more effective to replace these units versus saving the money to put towards a new building? That is a great question. And I think that's, I'll call it the $1 million question of, is it better to put the money in? And that also often gets to replacement costs. When has your car had it? When is it time to buy a new car? And I think it's somewhat subjective, but there's a lot of good infrastructure in your facilities that can be invested in. In some cases, it may make more sense to build new. And to be honest with you, I don't have the answer. I speak generically. That's always the question of when is it better to build new? And I guess I can't answer that question right now.
Yeah, I can just provide a little insight relative to our process for Melinda and the rest of the task force, that when we start looking at costs as part of our process here, we will get into looking at some of those things and some general comparisons between replacement versus new in cost. And the other thing that we'll also take a look at that has an impact on that is just some of the operational costs as well, beyond the mechanical infrastructure, but just also what the other things that it takes to run a particular school and what those costs are doing. And so we'll look at that in further detail when we look at all the cost aspects of our discussion. That'll be coming up a number of meetings down the road here, but we will have a more in-depth conversation than what Brian's able to give us insight on there.
Thank you, Tom, and thank you everyone for great questions.
Are there any other questions relative to the stuff that these guys presented here? And I know there was some questions that related to, how many buildings have this issue versus how many buildings have that issue. And when we take a look, Brian, correct me if I'm wrong, but when we take a look at the assets, the actual physical equipment, there you're able to give us a better idea of building to building what that equipment looks like. And in my conversation with you previously, some of the testing even that was done, when we have like designed buildings with very similar equipment in those buildings, it's very easy for us, based on the amount of projects you've done, to make some good comparisons there.
Absolutely. And the results after next week, the question of which buildings to focus on are a priority. I think next week there'll be a couple slides that will specifically answer that question, I believe, that will really help to give direction as to what is important. And it's based on age, and it's based on the assets in the building, the large major assets. When you look at those equipment, those assets that provide the ventilation and the temperature and humidity and makes all the sound in the space. So there's going to be a much greater discussion next week. Less material, but perhaps more discussion next week, I believe.
Are there other questions or comments that people have relative to what they talked about tonight? All right, so it is a little bit difficult in this virtual world that we're in, and we had some discussion with some of the folks as they were coming in tonight, and we're really hoping that in fairly short period of time here, we're able to get in and do those tours and actually go back to in-person meetings. Because, for instance, tonight's discussion around the things that they talked about and then the assets, we would have been able to take that all within one meeting, and it'd be a little bit more of a consistent discussion. So we understand it's a little bit difficult and choppy this way, but it just, it's what we're up against in the virtual world. Hopefully we'll be done with that fairly soon here. It sounds like we'll be able to fairly soon be able to get back to perhaps some in-person meetings. But I appreciate your patience in dealing with the situation there. Other questions?
While people are finding the unmute button, Tom, I'll get the list, that CO2 study for you on cognitive performance.
So we can go to small group discussion. The question that I had was not specific on this particular topic, because we're going to have a lot of discussion on this. Let me just see if I can get back to my screen here. Hang on one second. All right. So the question I was hoping to ask, and I guess I'll perhaps leave it optional for those who want to stay, because we're coming up on an hour and a half, and we have said that our meetings are going to run about an hour and a half. So I don't want to hold people over like we did a number of weeks ago. But what we really wanted to try to flesh out here a little bit is what questions do you want to ask of your fellow task force members about some of the things that we're talking about and some of the subjects that we've had so far. And we really haven't had that opportunity at all for people to really get a good broader feeling of where your fellow task force members are at because of the situation that we're in. And so I guess I'll leave it optional. I'd be happy to open up the rooms and maybe go and have that discussion for about 10 minutes for those who want to stay. And then we can do a little bit of a report out on that, and I can also provide some of that information back in an email afterwards. Is there a desire for folks to go and have a little bit of that discussion in small group?
And then another theme that came out was contingency planning. You know, with again so many unmet needs, what happens if you have other schools that that need to be shut down temporarily? What's the contingency plan? So those are a couple of highlights I heard. If anyone else from our group wants to chime in, that's be great.
Brenda, Sonia, you pretty much hit it.
Yep, sounds good, Jeff. Thanks.
Sure.
Yeah, that was good. Thank you.
So room 2 was Lee and Lori and Josh and John. Lori, you're muted.
You're on mute, Lori.
None of us were terribly surprised by what was presented tonight. That's not to say that we're not concerned. One of the questions that was very clearly stated that we all have is, how did we get here? So how can we prevent this in the future? And as we think about the whole district, are we going to have a conflict in equity from building to building in programs and learning environments? And then with the COVID situation, throwing a whole new monkey wrench into the situation, will the small class sizes that we support in our district be a huge benefit as we move into the fall?
Right. Yeah, I had some great points there, and things that we will continue to talk about. But equity is always a really important conversation that's had. I think you're right as far as your smaller class sizes may be an advantage as you're trying to deal with COVID. Some of the school districts that we deal with have 25 and 30 kids in a classroom, and that's going to be obviously much more difficult to try to deal with potentially, depending especially on what any of the regulations are that come down. So, and I think we'll try to address perhaps a little bit of how you got here. But more importantly than that is how do you not go back to this once you get things fixed? So those are great topics that we will continue to have conversation around. So appreciate that. Anything else from that group that you want to mention? Okay.
Anybody else?
All right. Room 1 was Josh and Kevin and Melinda and Trisha and Whitney. So anybody there want to try to represent some of what you talked about? Not everyone at once.
We had a lot of conversation about, you know what, I totally just blanked. I'm gonna pass it off.
Looked like you were
Yes,
getting ready, Whitney, or Josh. Go ahead.
Yeah. One of the things I took out of it is just a lot of what is going to be the cost. What is the high end of cost, the low end of cost? What's in the middle, and kind of what's reasonable for us to do with our budget? There was a lot just discussing that. Is what is the cost benefit, I guess, of our different options.
There's a lot of complexity to this because of kind of where you're at and the amount of work that really needs to be done. And you know, and we're gonna get through it, I think, and we're gonna have a nice or a decent recommendation to the school board. But you know, the fact of the matter is that you can't do it all at once, even if you'd like to. Number one, it's a really large dollar, you know, and especially with the economy that we may be facing coming out of COVID, at least in the short term. It's probably pretty unrealistic that the community would pass that large of a referendum all at once. The other thing is you just can't do that much physical work all at once either, even if you had all of that money. And so then it becomes how do you try to prioritize, you know, what you go after and how much in a particular period of time. And what we're gonna be able to get to through going through this process is to be able to do some prioritization there and really look at some windows that are likely to be something like, you know, 1 to 5 years. And then what do we look at, say 5 to 10 years, and then more of that planning around how do we not repeat this, you know, as far as a 10 to 15 year type plan. And then take a look at what that impact is. And one of the advantages, at least right at the moment, that we're seeing with a number of districts that we're working with is that the interest rates, at least, are very low right now. And so when we take a look at tax impact as a result of a potential referendum, there are some real advantages to being able to do some bond issuance right now, and so you can get a little bit more work done than traditionally you're able to get done in for the same amount of a tax impact. But it is complicated because you have the mechanical issues that you want to take care of in taking care of your kids. You have the equity issues that were brought up, and where do we start, you know? And then you also have the complexity in your district of kind of a bit of dissimilar types of infrastructure. And so I think somebody had made the point, and I don't know if they sent it to me in email or if they had put it on group chat, I think it was last week. But you know, what's an interesting thing to take a look at is that as you've built more recently, you have some of these larger schools like Discovery that have kind of that modern learning environment. And then you have your schools that are more in the downtown area, which are kind of the smaller single section schools. And then you have kind of another type of school that was built in between those things that kind of surround that downtown area. And not each have their pros and each have their cons, of course, but how do you try to deal with that issue in conjunction with these other things that you're looking to try to do? And again, there are discussions that we'll have. They're much easier had, you know, in person when we can be in a room and we can have those small group discussions. We can output to a large group and we can react to each other because we're sitting at a table and we're facing people face to face. And so I'm very anxious to get back to that because we're at the point where we really have to have more of those types of discussions, because I think the groundwork is pretty well being laid here between what we're doing in school, some of the conditions that we're looking at now. We'll do those tours, but those harder discussions will need to come right after that, and those are the ones that we really need to have in person. But what I will say is that this is not an entirely unusual situation, and we've dealt with the complexity of this before through this process. it generally results in a good recommendation that the district will be able to take advantage of for a number of years to come as part of that plan. But I have no preconceived notions of exactly where you're going to go because every community. So that wasn't necessarily meant to be an answer, but more of a comment, and I apologize it was longer. But anyone else have comments that you want to make, or just
I'm
some
gonna come back and
thoughts?
save myself here. One thing that we really focused on was some of our opinions on what we thought was most important, and there was definitely a disparity. And so it'll be really interesting moving forward on what the rest of the group thinks and how the community is going to perceive that. And there's obviously a lot of needs, and so it'll just be I'm excited to see what it comes down to with our recommendations.
Yeah. And that's always a balance as to what you in a community your size, even smaller communities. I mean, you're generally not going to get 100% consensus on anything, and so trying to develop what those priorities are is complex. You may even send a couple of different options on how to deal with some of these things to the school board, and the school board may need to weigh through that. Ultimately, they're going to make the decision either way, but I believe that they will definitely take the input from this group seriously. And the other thing is that you hope that you have a strong strategic plan, mission, vision, values, beliefs in your district, that you're able to go back and look at those and try to apply, the decisions that you're making here against what those values and beliefs of the district are. And so that's some of the importance of that strategic plan as well, is to be able to tie that out. Because of course that was also done, my understanding, I was not a part of the process, but my understanding, done with community input as well. So. Other thoughts that folks have?
I want to thank everybody for sticking around, because this is really helpful. This is what we kind of missed by not having the face-to-face meetings.
Yeah, absolutely. Absolutely. I personally would prefer and enjoy doing this, but I know a lot of people don't necessarily have the ability or the patience to do it online, looking at a computer screen.
I would go back to the equity comments that we had early on in the process. And I think people will buy into the idea that the equity would be equity more in programming than necessarily in the physical building their students are in. And that we probably have to concentrate on allowing that to happen that way. And also looking, when we get into the individual buildings, to kind of assess those buildings so that we're not putting a bunch of, for example, lighting and interior work into a building that's going to need a roof in 2 years and then it's all shot anyway, so that we maximize and really think about the process of how we go about upgrading these buildings.
Yeah, yeah.
And what the tipping points are for refurbishing versus replacing.
Yeah, and there's some generalities that we can take a look at for replacement versus repair, if you will. And we'll look at that from a financial perspective. They're not perfect, they never are, but there are some generalities you can take a look at from that standpoint. The equity piece is a really good conversation, and equity doesn't mean equal, and you can definitely work to achieve equity even though your buildings are not the same. Discovery is a 6-section building, meaning you have six classrooms in each grade. And so it's a fairly large elementary school, whereas some of your schools that are closer to the downtown area are single section classrooms. So there's one classroom per grade, and that's quite different from a physical standpoint, but that doesn't mean that you can't have equity from a programming standpoint in those two different types of structures. And so but sometimes the costs are a little bit different in achieving that equity, and that's something really that the community just needs to commit to, whether or not they're willing to be there, and hopefully we have a good broad representation of the community on this task force where some of those conversations can be had, and when you look at costs, a single section school sometimes does have some additional operating costs because, and again, I'm not trying to necessarily make a hard comparison, but if you get a 4 or a 6 section school versus a 1 section school times 4, you've got 4 principals, for instance, and you've got 4 librarians sometimes, and so when you look at some of those operational costs, sometimes they're a little bit higher. Now, are there ways to deal with the operational costs that can help bring that in line? That there are some things that can sometimes be done that way, but as you guys know, one of the complexities of trying to do all this work is that budget that you have and how much money is allocated to the educational side of things versus the infrastructure side of things, and so unfortunately the operational cost does weigh into a person's evaluation of what the right answer, the right direction is, and again, it doesn't matter what I think, it matters what you guys think, but those are some difficult conversations that we'll have, and are again much easier had in person, but those are some conversations that will have to be looked at. So not an easy answer that comes quickly.
Okay, well, I'm going to sign off. Thank you, everybody. It was a good meeting.
You bet.
Have a good week, everybody.
Thanks, Lori. You too.
Good night, everyone.
Conversations to continue.